for this lab, we're going to be using the drawbar bench. So what this lab entails is you'll need the initial diameter, final diameter, and initial length of this bar right here. Most, especially the thicker part of the bar, because that's what's going to go through the die and give us like a change in length and diameter. So Jesse here will take the length, the measurement of initial and length and diameter.
Like it's 3 points. 3.313. Yeah. So 0.313.
Write it down. So we just need the measurements of the thicker part of the rod. So I'm not going to take the whole thing. And we are at 4, 5, 6. Oops. We are at 6.902. Yes, 6.902. Okay. Write it down this.
We're starting with this 304 die.
Oh. So we're going to wax that thicker part to make it go through the die easier, or more easily, I guess I should say. So we put it through.
Which one is that? Which one?
Bring this forward a bit more. We put it through. We want to clamp it, make sure it's secure. So, oh, sorry. There you go. Test it, just a bit. Yeah, we're good, we're good. Put it back. Bring it back down. So, we want to rename our file so that we know what exactly we did. Yeah, I can't see. Let's go back up. Okay, so, Jesse, are you ready?
Hold on.
Are you ready?
Yeah.
Okay, go. There we go. And we're just going to let this run through. In the meantime, we need final diameter.
All right.
Oh.
These shorter ones are here.
Okay. There you go. Here's our file. Oh, I don't think we do that.
0.311. Yeah, 0.311.
There we go. Here's our first one.
We'll talk about what to do with this data during recitation, but for now, you guys will have the files available on Brightspace to download.
Okay.
All right, so now we're going to do the second die size. The first die size was, let's just confirm that.
Oh, that was, what's the smallest one?
0.304.
The bigger one.
The bigger one?
Yeah, 0.308.
0.308.
Okay, yeah.
So that was the 308 die.
Yes.
All right, so we did the larger die diameter first. That was the 0.308. Now we're going to do the 0.304. So basically what we're doing here is we're taking a piece of metal, putting it through a hole that's a smaller diameter than it currently is, and elongating and making the cross-section smaller. You'll note that the size that the bar comes out is not the same size as the die it went through, because the metal has a tendency to spring back after it comes through that hole. So now Jesse is taking the initial diameter of the second bar,
And the initial length.
0.312.
0.312, and the length.
And they should all be around the same size. So this one is 7 point, yes, 7.048.
Bit longer.
Can you fill in both? Again, wax.
Yeah, as we'll talk about in class, lubrication is really important during these processes to reduce our amount of friction. If you were doing this live and in person, you'd discover that when this comes through these dies, it actually heats up due to friction. So the bar itself gets warm. It doesn't get hot, but it gets warm. The lubrication we're using on there helps to decrease that and make it easier for the piece of metal to go through. So this happens to be a human-powered draw bench used for experimental purposes. In a
No.
mechanical setting, you would have, in a realistic setting, you wouldn't have somebody turning a handle here. The key to this with this lab is to have a continuous speed on the turning of the handle, or else you get error in your data. So that's on Jesse to make sure he's doing this properly.
If he doesn't, you get the wrong data. Ready? Okay, go.
So as he turns the handle, we see the bar being pulled through the die. So now he's going to measure the final diameter.
Okay.
Wow.
What did we get for a diameter?
0.306.
Okay, so I actually think, wasn't this one smaller than the previous one?
This one was just a bit smaller, but now it's even smaller.
So do we think this was the 304 die?
I think, yeah.
It was.
Oh, we had said,
We said the other one was 308, so yeah, this is
This is
304.
304.
okay, 304, okay, yes, sorry. So yeah, this went through the smaller hole, so it required some additional force on Jesse's part to get it through there, and we see that the diameter again has come down. But not to the size of the hole. So it went through a 304 hole and came out to be about 306. So yeah, you do
And
get
the
some
force-
rebound.
The force used is higher than the first one.
Yeah,
So yeah, we have
And then you
higher
had a
force. And the dip that you see there, so when you go to analyze this data, you're going to want to take these dips out, and we'll talk about how to do that in recitation from this data file. But that's an inconsistency during the turning of the handle. But we can account for that. Basically, you just want to take the average force, which you can get from this graph, and by cutting out erroneous data. All right, so that is our draw bench portion. So what we'll end up doing is I'll download these files, and they'll be available for you on Brightspace, so you can use those to get your force data for the draw bench. The next step is going to be going over to tensile testing, but we'll do that on a separate video.